So for this problem, we're solving triangle ABC given angle B is 60 degrees, angle C is 75 degrees, and side A is equal to the square root of 2. So to start this off, we're going to go ahead and fill in all of our given information into our solution so that we know what's left over to solve for. And now that we have that, we know we're solving for angle A, side B, and side C. So to start off with, we'll solve for angle A because we know two angles of this triangle, and we know that when you add all three angles of the triangle, the result has to be 180 degrees. So angle A plus angle B, which is 60, plus angle C, which is 75, is equal to 180 degrees. So if we subtract 60 degrees from each side of the equation, and subtract 75 degrees from each side of the equation, we'll get angle A, which is 45 degrees. So in order to solve this problem, we're not going to be able to use only given information. We're going to have to use this 45 degrees that we just found to use the law of sines. And just to be clear on why the law of sines applies, we should really quickly fill in this triangle that we have. This is technically the first thing that you want to do with any of these problems, but we'll just go ahead and do it now really quick. So we were given angle B and angle C, and side A is across from angle A. So notice we were given angle, and then the side adjacent to it, and then the angle adjacent to that. So we were given angle, side, angle, which can be solved using the law of sines. So we're going to have to use the information we solved for, and on top of that, notice that approximation is not allowed. So since approximation isn't allowed, we need exact values for all of our answers. So no calculator is going to be used to solve this problem. And it'll show that calculators aren't actually required for all of these problems. So going from here, we always want to solve for the smaller side or smaller angle first. Again, it's really only that you have to do it when solving for the angle first, but it's just a good habit to always stick with solving for the smaller one first. This way you don't accidentally mix them up. So we're going to want to solve for side B first, since angle B is smaller. So to solve for it, we'll use the law of sines. B over sine of angle B is 60 degrees equals, we can't use C because C is unknown, so we'll use A, which is the square root of 2 over sine of A is sine of 45 degrees. And now we want to get side B alone. To do that, we'll multiply each side of the equation by sine of 60 degrees, which gives us B equals the square root of 2 times sine of 60 degrees over sine of 45 degrees. Remember, because we multiplied each side by sine of 60, it canceled out in the denominator over here, and on the right you could put sine of 60 over 1 and multiply straight across to get the square root 2 sine 60 over sine of 45. And now notice these are both unit circle angles, so we can actually solve this without a calculator. We get B equals the square root of 2 times sine of 60 is the square root of 3 over 2 all over sine of 45 is the square root of 2 over 2. I'm going to go ahead and put the square root 2 over 1 just so it fits in with our other fractions. And now from here, notice that we can take this fraction that we're dividing by and change it to multiplication by the reciprocal. So we'll get b equals the square root of 2 over 1 times the square root of 3 over 2 times, instead of dividing by the square root of 2 over 2, we have times 2 over the square root of 2. And now notice what we can cancel. Because we're multiplying all three fractions, if anything's a common factor in the top and bottom, it'll cancel out. So this 2 in the top and bottom cancels, and the square root of 2 in the top and bottom cancels, leaving us with the square root of 3 over 1, meaning b is just equal to the square root of 3. Now we want to solve for side C. And we're going to use the law of sines again. So it's tempting to want to use something like the Pythagorean theorem, but remember that doesn't work unless you're dealing with a right triangle, which we don't have. So we need to use c over sine of c. So c over sine of 75 degrees equals, and now we need to use either b over sine of b or a over sine of a. Technically, in this problem, both of these have information that we solved for. So you're technically allowed to use either one of these. I'm just going to go ahead and use a over sine of a, since we just used that in the previous one. So we get a is the square root of 2 over sine of a is 45 degrees. So simplifying, we have c over sine of c. Sorry, let me undo this. To solve for c, that is, we have to multiply everything by sine of 75. Just like we solved for b over here. And when we do that, again, it's going to cancel out on the left, leaving us with c equals the square root of 2 times sine of 75 degrees over sine of 45 is the square root of 2 over 2. Again, we're dividing by a fraction, so let's go ahead and change that to multiplying by the reciprocal. So we get the square root of 2 times sine of 75 degrees times, instead of dividing by the square root of 2 over 2, remember we have 2 over the square root of 2 being multiplied. So this square root of 2 will cancel out with this one, leaving us with c equals 2 times sine of 75 degrees. And at this point you might be thinking, well, I guess we just have to leave it there because we don't know sine of this angle without a calculator. But remember that this can be solved using our sum identity. This could be rewritten as 2 times sine of 45 degrees plus 30 degrees. This could also be solved using a half angle identity, sine of 150 degrees over 2. But we'll just go ahead and use this one as it'll work out a little bit nicer. So simplifying, we get 2, I'm actually going to write this off a little bit more to the left because this is a bit long. We get 2 times sine of 45 plus 30 degrees. We're going to use the sum identity for sine, which says we take sine of the first angle, which is 45, times cosine of the second angle, which is 30, plus sine of the second angle, which is 30, times cosine of the first angle, which is 45. You might normally see it as sine of 45 times cosine of 30 plus cosine of 45 times sine of 30, but just remember when you're multiplying, order doesn't matter, so this sine of 30 times cosine of 45 can be written in either order. And now simplifying from here, we get 2 times sine of 45 is the square root of 2 over 2 times cosine of 30 is the square root of 3 over 2 plus sine of 30 is 1/2 times cosine of 45 is the square root of 2 over 2. We'll simplify to get 2 times square root of 2 times the square root of 3 is the square root of 6 over 2 times 2 is 4 plus 1 times the square root of 2 is the square root of 2 over 2 times 2 is 4. When we distribute the 2 to each term, it's going to cancel a factor of 2 from each denominator. So each of these 4's is going to simplify to become a 2, meaning we're going to get the square root of 6 over 2 plus the square root of 2 over 2. And now we're finally there. When you have the same denominator, you can add the numerators together and keep that denominator. That's for any fraction you deal with. So we end up with the square root of 6 plus the square root of 2 all over 2. And that is the complete solution to this triangle that started with angle B is 60 degrees, angle C is 75 degrees, and side A is the square root of 2.